so I'm going to pass around the finished product. So half of you are going to see what this is and have no idea. And then by the time it gets to the other half of you, you'll know exactly what it is. But play around with it. If you put this is a super strong magnet, so don't put it near anything because it'll like go right to it and make a really loud noise. Just hold it about this far away and just spin it around and look at what's happening inside. It's really cool. And I'll get to explaining why it's doing what it's doing. So, when I was a young kid, I had a cat. Her name was Daisy. And like many people have done in the past, I used to love taking the flashlight, shine it on the wall, and watch her run repeatedly into the wall, trying to attack this flashlight. We've all done it many times. I'm sure it's really entertaining. It's cruel, but we do it because we really enjoy it. And I always thought it was fascinating that she had no idea what was happening, but also that I could put my hand in the way of the light and I could stop it. And then she was like, where'd it go? Like it was actually, she had no idea. And, but even more so, I was like, well, why can I do that? Why, how can light, like, I thought light was fascinating. And I'm not the only one. There's other people that are in the same way. They think light is, they study light, and there's a lot of scientists, there's a whole study of, quantum mechanics studies it a lot. But to me, I think that light, we look at light the way that it could be used in the practical world in eventually we'll get there. Eventually in the future, maybe we'll think of something that's really, really cool with light. What I'm getting towards is an entertainment now. You see a lot with holograms. And it's all an entertainment, with the exception of one of these pictures. They're all entertainment. And to me, it's fascinating if we could work with holograms and try to create holograms because of the implications just from these 4 pictures. Yoda, you can have a meeting and you're not even there. And it's not the same as Skype. You can actually see people sitting in the seats around you. Just to think, just thinking of all the majors that can benefit from that alone. In construction, if you could just take something and go like this and be moving around and you don't like it, just go like that and then start the next project. If you want to teach somebody something, show them a big layout. If you want to teach someone about the building of the pyramids, get a 3D image and you can zoom in, you can zoom out, look at where it is, why it's there. If you were in business, this is like the Google Glasses kind of. What if like making an appointment or a meeting was as easy as just, and that's it, and there was nothing else, there's nothing you had to actually take out. To me, that would just be fantastic. So, in my 5% time, I was sitting in the back of the room, and I had just watched a video about ferrofluid, which is a magnetic fluid. I decided, since I have to do an independent project for Advanced and Organic anyway, why not come up with a project idea that I could try to target holograms, try to focus on a hologram. So my first goal was, how could I do that? What would it be made of? And I thought, a gas? No. How do you control a gas? I couldn't think of a good way. Like, you'd have to be so in control of the pressure, and it'd be too much of a hassle. And I was like, well, what if you can get a liquid that you can control without touching it? What if you could use magnetism? So my idea was, I was sitting back there staring at a lamppost out there. What if you had a stick, and at the top of the stick you had a magnet, very much like that one, and you pour it on this ferrofluid. So it would look just like that, but it would be all around the magnet. And then if you had it encased in some kind of sphere where you can impose electromagnetism from different sides. So you impose a magnetic field this way, and all of a sudden all the spikes will shift this way. Would be the very elementary way of looking at it. Eventually I would give this off to an engineer and say, okay, come up with a fancy program to work with it. Then my next thing was, okay, well then it's just this big black brick. No one really thinks, that's not a hologram. So it's like, what if I can get it to fluoresce? So if I can get it to glow. Now this is what's different. No one's ever done this. People have made ferrofluid, no problem before. I actually just used the literature procedure to make it, which is what's being passed around. My idea was, what if I can actually get it to glow? So you have it on this stick, on this magnet, and you turn on a black light from underneath, and now it's glowing, and you can control it. Couldn't really think of a much more accurate way to hit what a hologram is. So, went into the lab, and I did it. I took a literature procedure for how to make ferrofluid, and between the second to last and last step, I added what's called rhodamine B. Rhodamine B is a fluorescent dye that they use all the time. It glows even if it's not under UV light. Like if you concentrate it, it'll just glow. It's this bright orange color. There were a lot of roadblocks along the way, as there always are in science. The first 3 times I tried to make just regular ferrofluid, it failed miserably, and I got a granular magnet type thing. I was getting really frustrated with the nature of science. I eventually found out that one of the solvents I was using, this one right here, freezes at room temperature. So it had actually been going into the thing and then freezing, and then it wasn't working. So then I had to keep that thing constantly warm the whole time throughout the entire project. And then the time I had to do it, the one time after that, is the result of what you're seeing there. Also, if you look right here, this is shipped in a container about this big, about this wide. It's a carcinogen. If you breathe it in, you die, you'll pass out. All these things that are just not good to go. It's called iron 2 chloride. And so I had to work with my advisor. It decomposes almost instantly if it touches air at all. Oxygen's really, really bad for it. So you can imagine how that makes it difficult, especially because we don't have a glove box on campus. Or the glove box we have is actually just a bag you have to fill up. Not fun. So that was another roadblock I hit. So basically I took these 2 solutions, 1:4 ratio, put them together, centrifuged it, which is what that machine is, which just separated out what's called the magnetite, which is the actual ferrofluid. And then I just spun it under vacuum to take out all of the, I used ammonium hydroxide. In the end, I was able to make it. But I failed, but I succeeded, which was really interesting. I succeeded in making a ferrofluid. This is the ferrofluid without any dye or anything. It's kind of hard to see. I had a bad quality camera. But the ferrofluid actually spikes, so I know I actually made ferrofluid. When it comes to the fluorescing dye, my idea was to attach it to the outer edge. So if you can imagine like a globule of the ferrofluid, I wanted to all around it, I wanted it to glow. I didn't get that. What I actually got was a mixture of ferrofluid and the dye on top of it. They're not attached at all. So I did fail in actually attaching it and making it. However, you'll see in the clip I'm about to show, that doesn't mean I didn't create something that's different, because now instead of having something that when you put the magnet underneath it will spike and it will glow with the spike, what happens is when you don't have it there, the ferrofluid goes underneath the dye, which glows, but once you put the magnet there, the spikes go up and then you can't see the dye. So it's the exact opposite of what I wanted to do, which still could have application. And just right then, one of the kids in lab who was with me was like, oh, that'd be really cool, like if you put that in a sound system in a car, and then like the lights could be on, they would like turn off with the music if you synced it up to like electromagnets with the bass. And I was like, yes, all right. There are ideas with this. I failed, but I didn't at the same time. So let's see if this video will work. Okay, so it's kind of hard to see again because it's bad quality, but so as you move the magnet underneath, you'll notice the spikes, and then as you move the magnet away, you'll notice that it starts glowing because they all fall down. And then again, hard to see, bad quality. But in my opinion, there are other applications that you could use this for. I plan on trying it again, seeing if maybe there's a different synthetic scheme that I could do that could maybe integrate it more in. I'm in the process of characterizing it, so seeing just how magnetic it is. I'd like to do it again and measure how high the spikes go as a function of how long it's been since I made them, because I've noticed that they aren't going nearly as high now as they were then. And this is basically the result of my 5% time project. Thank you.
Questions or comments?
You said you used a solution that would freeze at room temperature, right?
Mm-hmm.
How come it's not freezing now when it's mixed in with the oil stuff?
It's when it's alone. When it's the pure solution, it freezes at room temperature. So I had to integrate it in, and then you get, it's called magnetite. The magnetite settles in between it, and then its properties change. And I think it freezes now at way colder.
So you looking at electromagnets? So it would be
Yeah, because to me that's the coolest way you can control it. Especially if you were to eventually put it on the stick, on top of a stick on a magnet. Then I would really like to look into like what if you were to impose it more and more and more from here, and more and more and more from here. And I always like to say, you can have a program for the shape of a house.
Or
You
even
know what I mean?
changing the rotation of the magnet. So
Right.
you could have like a Leslie effect with the magnet.
You could do that too. Yeah. I just want to make it and then give it to an engineer and say, have fun.
You mentioned you used something called a glove box. What is that?
I didn't use the glove box. I wish I could have. A glove box is something where, well, Morgan, she actually used it in the lab. A glove box is something where there's no oxygen, or air at all, because the air you're breathing is 70% nitrogen, 21% oxygen, and then point something percent of everything else. And all those things work really badly with that iron 2 chloride, and they make it go bad almost instantly. So it can't touch anything. It can't touch nitrogen. Oh no, it can touch nitrogen, but it can't touch oxygen, because that'll break it down. So I had to instead use it in the fume hood with argon being pumped in the entire time, and then it was really just a pain in the butt. And it's super carcinogenic and bad for you, so I couldn't spill it on the way to the bench to measure it either.
The thing that strikes me with this presentation is, so we're thinking about Gardner. Gardner has these threefold schema for thinking about creativity. The individual, the field, and the domain. And it strikes me that in order to do a project like this, you have to have quite a bit of familiarity with a domain. Could you just, in 30 seconds, which is almost impossible to do, could you tell me everything you need to learn to be able to do this project?
You'd have to be a chemist, just because I can't see you overcoming the problems I ran into in the lab without having the experience of having been in the lab.
What kind of chemistry do I need to know is, I guess, my question.
This is specifically called colloidal chemistry, because you're making a colloid. So imagine when you put salt into water and it dissolves. Imagine that, but at the molecular level, a bunch of little molecules floating around, and that's what's called a colloid.
Thank you very much. All right.
Okay.